Sustainability. We all hear the word every day, but for engineers and scientists, it's not just a slogan, it's a constraint. Just like pressure, temperature, or flow rate, sustainability defines the limits of what our systems can handle. Think of Earth as the biggest chemical plant ever built. And here's the scary part. We're running it way past design capacity. The inputs, things like resources, fuels, and water, are being consumed faster than nature can replace them. The outputs, carbon dioxide, waste, and heat, are dumped faster than ecosystems can absorb. And this is where chemical engineering steps in, redesigning processes so the balances stabilize, not just for efficiency today, but for survival tomorrow. Before we go deeper, let's pause for a clear definition. Sustainability means being able to keep systems running over time without destroying the resources they depend on. Take a forest, for example. If you cut trees at the same rate they regrow, that's sustainable. If you cut them faster, that's not. Sustainable development goes a step further. It's about meeting today's needs without blocking future generations from meeting theirs. With the three pillars, environment, economy, and society, think renewable energy replacing fossil fuels. Think closed-loop water systems in factories, where water is recycled instead of wasted. These aren't abstract ideas, they're practical strategies to keep the global system in balance. Why chemical engineers are key. We design processes that turn raw resources into useful products. We decide how much energy, water, and raw material a process uses, and how much waste it creates. Now, to have an analogy, think of society as one giant chemical plant. Resources go in, waste comes out. The challenge is to maximize efficiency while minimizing harm. Therefore, a chemical engineer is basically the planet's process engineer. Let's zoom out to the planetary scale. Earth is a closed system. That means resources are limited and the carbon budget is not endless. Thermodynamics sets the ground rules here. Every process wastes some energy through heat, friction, entropy. We can't escape those losses. Take power plants, for example. Traditional ones run at only 30 to 40% efficiency. Most of the energy is gone before it ever reaches us. But when we combine renewables with storage, we can design systems that achieve much higher efficiency. In other words, sustainability is not just about what we do. It's about respecting the hard physical limits of our planet. Energy is one side of the story, but chemistry is the other. The carbon cycle shows us how carbon moves through the air, the oceans, and life itself. And here's the key insight. Carbon dioxide doesn't have to be waste, it can be a resource. That's why new processes are emerging. Carbon capture and utilization can turn CO2 into fuels or chemicals. Green hydrogen, produced through electrolysis powered by renewable electricity, can replace fossil fuels. And circular chemistry lets us recycle plastics back into their original building blocks instead of throwing them away. Each of these examples points to the same goal, shifting from a one-way path of resource to waste into loops where materials keep cycling. Now let's bring sustainability and sustainable development to life with a real-world example. Think about a simple disposable coffee cup. At first glance, it feels harmless, a little convenience we use almost every day. But behind that one cup is an entire hidden story. To make it, we need paper from trees. We need plastic lining, usually made from petroleum. We need water for processing and energy to power the factories. And when we're done, that cup often ends up in a landfill or worse, out in nature, adding to pollution and greenhouse gas emissions. Now, imagine this not once, but billions of times every single year. Suddenly, one small habit scales up into a massive burden for the planet. And this is what sustainability is really asking. Can our current way of living continue like this without depleting resources or harming ecosystems? Clearly, the answer is no. But here's the second step: sustainable development. It doesn't just say, stop using cups. Instead, it looks for smarter solutions that balance human needs with long-term well-being. For example, companies can design reusable cups or compostable alternatives. Cities can build recycling systems that actually recover and reuse the materials. Cafes can offer cup return programs where your cup gets collected, washed, and put back into circulation. And that's the key difference. Sustainability is the question. Can this last? Sustainable development is the answer. How can we make it last while still improving people's lives? So the next time you grab your morning coffee, remember, your choice isn't just about caffeine, it's about shaping the kind of future we're building one cup at a time. All of this raises a bigger question. Why does it matter right now? First, the climate clock is ticking. Reports from the IPCC remind us that the deadlines for net zero are coming fast. Second, the economy is shifting. Sustainability isn't just good for the planet, it's good business. In most cases, renewable energy is already cheaper than coal, and green hydrogen could grow into a trillion-dollar industry. And third, it's about fairness. Everyone deserves clean water, clean air, and access to energy. If we ignore sustainability, it's like running a chemical reactor in runaway mode. Sure, you get a short burst of production, but eventually the system explodes, and we can't afford that with our only planet. So where do we go from here? The future of sustainability is being written right now. Digitalization and artificial intelligence will optimize industrial processes, cutting waste and boosting efficiency. Circular economies will take off, powered by chemical recycling that turns waste back into resources. Electrification of industry through microwaves, plasma, and renewable-driven heat will replace fossil fuel combustion, and we won't just measure impact with slogans. Techno-economic and life cycle assessments will make sure the changes are real, not just greenwashing. Most importantly, progress will depend on collaboration. Engineers, policymakers, and society working together, building not just technologies, but ecosystems that are truly sustainable. So here's the big picture. Sustainable development is not a buzzword. It's an engineering challenge, a social contract, and a personal responsibility. From the cement in our buildings, to the fertilizers in our food, to the plastics in our laptops, every product is part of a chemical journey, and we, as scientists, engineers, and informed citizens, have the power to redesign that journey. The question is, will we? If this journey opened your eyes, imagine what we can build together. Industries powered by clean fuels, cities running on circular systems, a future where engineering equals sustainability. Thanks for watching. Don't forget to like, share this with a curious friend, and subscribe for more deep dives into the science shaping our future. See you in the next one.